Hey class, it's Ms. Richardson. Today we're going to talk about systems with three variables, and this is found in section 3-5, part 1 of your book. Again, our objective is to solve equations in three variables using elimination. Okay, so in our first example, we are asked to use elimination to solve our system. In the past, we have only talked about two unknown variables with two equations for a system, but now we're talking about three variables with three equations. So the way to solve is to deal with two equations at a time, but we have to choose what variable we want to eliminate. So I'm going to write the first two and the second two. So with these two, I will have 2x minus y plus z equals 4, and x plus 3y minus z equals 11. At this point, it's very clear to us using elimination that the z should be eliminated. So we're going to eliminate the z's and then solve vertically. So I have 3x plus 2y equals 15. Now, if I chose to eliminate z on the first two, then I have to choose to eliminate z on the second two. So here are the second two rewritten. So that's x plus 3y minus z equals 11. And I have 4x plus y minus z equals 14. Again, I have to choose to eliminate z, but in this case, both of my z's are negative, so I have to make one of them positive to make them opposites of one another. So we're going to multiply the top one, or excuse me, the bottom one by -1. So when I rewrite that, I have x plus 3y minus z equals 11, and negative 4x minus y plus z equals positive, excuse me, that's wrong. That should be negative 14. Okay, our z's will go away, and I'm left with negative 3x plus 2y equals negative 3. Okay, so now that I've got those two, I'm going to rewrite the two of them in the center. So I have that's positive 3x plus 2y equals 15. That was the first one. And then I have negative 3x plus 2y equals negative 3. And that works out so nicely because at this point now we have to eliminate another variable. So the variable that we'll eliminate this time is x. So the x's are gone. I'm left with 4y equal to 12, and that's even more perfect because when I divide by 4, y will equal 3. So we've got our first answer of the 3. Now it is our choice at this point whether we want to substitute into the pink final answer here, or if I want to substitute in the blue final answer there. So I'm going to choose to substitute into the pink one because it is there are no negatives. So here we go. I'll have 3x plus 2 times 3 equals 15. That gives me 3x plus 6 equal to 15. If I subtract 6, I'll get 3x equal to 9. Divide by 3. X will equal 3. So now we have two answers. And at this point, now that we have two answers to our variables, we can actually substitute those two answers into any of the three original equations. I'm going to choose an equation with the least amount of negatives. In this case, they all have the same amount of negatives. So I'm just going to do the first one. So I'm going to deal with this equation right here. So here we go. I have 2 times 3, that's my x, minus y, which is 3, plus z equals 4. So that's 6 minus 3 plus z equals 4. 6 minus 3 is 3. So 3 plus z, by the way, these are z's, equals 4. If I subtract 3, then z will equal 1. So our final answer has to be in an ordered pair format. And in fact, I can't even call it an ordered pair. It's probably closer to an ordered triplet because our form will be in the x, y, z format. So our final answer will be 3, 3, 1. And your answer must be written as a point. Okay? Okay, so in try one, we'll start that process again. So again, we start with the first two equations. So I have x minus y plus z equal to -1. And then I have, by the way, that's a z. Then I have x plus y plus 3z, that's a plus, equal to -3. Okay, the y's will be eliminated. So I'm left with 2x plus 4z equal to -4. That's our first fixed one. Now let's deal with the second two. Okay, I have x plus y plus 3z equal to -3, and I also have 2x minus y plus 2z equal to 0. Again, I chose to eliminate the y's on the first one, so I have to eliminate the y's on the second one, but that's good because they're already ready to be eliminated. So I'm left with 3x plus 5z equal to -3. All right, now that I've got those two, I need to stack those two. So I have 2x plus 4z equals -4, and I have 3x plus 5z equal to -3. All right, at this point we need to choose whether we want to eliminate x or z. I'm going to go ahead and choose to eliminate my x's. So to eliminate x, I need to find the least common multiple and make them opposites. The least common multiple of 2 and 3 is 6, so I'm going to make the top one positive 6 by multiplying by 3, and make the bottom one negative 6 by multiplying by -2. So to rewrite this, I will now have 6x plus 12z equals -12, and the next one I would have -6x minus 10z equal to 6. So I'm left with 2z equal to -6. If I divide by 2, z will equal -3. So that's our first answer. If I know that z is equal to -3, I should choose to substitute it again either into this pink equation or to this blue equation. Again, I should choose the one with the least amount of negatives, but again, they're the same. So I'm going to again choose the pink one. So I'll have 2x plus 4 times z, which is -3, equal to -4. So that's 2x minus 12 equals -4. If I add 12, I will have 2x is equal to 8. If I divide by 2, x is equal to 4. Finally, now that I have an x and a z, I should choose to substitute it into one of the top 3 originals. Again, I'm going to choose the one with the least amount of negatives. It looks like the second and the third equation have the least amount of negatives, so I'm going to actually choose the second equation. So here we go. X is 4 plus y, we don't know, plus 3 times z, which is -3, equals -3. Okay, that would give us 4 plus y minus 9 equals -3. 4 minus 9 are like terms, right? 4 minus 9 is -5, so I'll have y minus 5 equals -3. If I add 5, we'll have y equals 2. So remember, our final format should be an x, y, z format as a point. So that should be 4, 2, -3 is our final answer. Okay, in example 2, again we'll begin to solve the same way using elimination. So again, we're going to start with our first two. So we have x plus y plus 2z equals 3. And we have 2x plus y plus 3z equals 7. Okay, we have to choose what we want to eliminate. In this case, I am going to decide to choose my y's because they're single, and if I'm going to eliminate one, I just need to make one of them negative. So I'm going to choose to change the top equation to a negative. That's the negative sign, by the way. All right, so if I distribute the negative throughout, I should have negative x minus y minus 2z equal to negative 3. And on the second one, I should have 2x plus y plus 3z equal to 7. Once I'm done, I will have x plus z equal to 4. Okay, now I need to deal with the second two. The second two, I will have 2x plus y plus 3z equal to 7. I have negative x minus 2y plus z equal to 10. Okay, again, if I chose y on the first one, I have to choose y on the second one. I already have a negative 2y, so I'm going to make the top one a positive 2y, so I need to multiply by 2 to everything. So that'll be 4x plus 2y plus 6z equal to 14. And I have negative x minus 2y plus z equal to 10. Okay, the y's will go away, and I'm left with 3x plus 7z equal to 24. Okay, we're going to put those two equations together now. So x plus, by the way, sorry, should have boxed those in. So x plus z equals 4. And the blue one, we have 3x plus 7z equal to 24. Again, I have to choose what I want to eliminate. So I'm going to choose to eliminate the x's by making the top one a negative 3. So here we go, negative 3x minus 3z equals negative 12. And the second one is 3x plus 7z equal to 24. X's are gone. I'm left with 4z equal to 12. So that means that z is going to equal 3. That's our first answer. After that, I need to substitute into either the pink equation or the blue equation. And I'm going to choose the pink one again. So I have x plus z, which is 3, equal to 4. So that must mean that x equals 1. Now that I've got the two of them, I have x and z, I need to substitute into, again, one of the originals. And I'm going to choose the top equation. I'm going to choose the top equation to substitute into. So that will leave me with 1 plus y plus 2 times 3 equals 3. That's going to be 1 plus y plus 6 equals 3. That's 7 plus y equals 3. If I subtract 7, that's minus 7. I will have that y equals negative 4. So our final answer should be 1, negative 4, positive 3. Okay, our last try. Again, we need to start by putting the first two equations together. So that's x minus 2y plus 3z equal to 12. And 2x minus y minus 2z equals 5. At this point, we need to determine what we want to eliminate. Do we want to eliminate x, y, or z? For this problem, it wouldn't matter if I chose to eliminate x or y. They're doing about the same thing. Z, I would not want to eliminate. I'm going to choose to eliminate x. So if I eliminate x, that means I need to multiply the top equation by negative 2. So I need to rewrite the top one. So here we go. Negative 2x plus 4y minus 6z equals negative 24. And the bottom one will be 2x minus y minus 2z equals 5. X's are gone. I'm left with 3y minus 8z equal to negative 19. That will be our first equation. All right, the next one, I need to deal with the second two. So I have 2x plus, nope, that's not a plus. Oops. 2x minus y minus 2z, that's a z, equal to 5. And then 2x plus 2y minus z equal to 4. If I eliminate the x's the first time, I need to eliminate the x's the second time, so I'm going to do that by multiplying the first one by negative or negative 1. Same thing. Here we go. That makes that negative 2x plus y plus 2z equal to negative 5. 2x plus 2y minus z equals 4. Okay, x's are gone. I'm left with 3y plus z equal to negative 1. Okay, I need to put both of them into, put the pink and the blue together. So I have 3y minus 8z equal to negative 19. And the blue one is 3y plus z equal to negative 1. Okay, at this point I need to choose what I want to eliminate. So I'm going to choose to eliminate z by multiplying the second equation by 8. So when I rewrite it, I have 3y minus 8z equals negative 19. And then I have 24y plus 8z equals negative 8. I'm going to be left with 27y equal to negative 27, so y will equal negative 1. That's our first answer. Again, I should then substitute into either the pink or the blue. I'm going to choose the blue this time. So I'll have 3 times y, which is negative 1, plus z equal to negative 1. That gives me negative 3 plus z equal to negative 1. If I add 3 to both sides, I will get that z equals 2. Got two answers now. Now I need to substitute y and z into one of my original 3. I'm going to choose the first equation. So here we go. This equation here. So x minus 2 times y, which is negative 1, plus 3 times z, which is now 2, equal to 12. That's going to be, if I use order of operations, I should have x plus 2 plus 6 equal to 12. That's really x plus 8 equal to 12. If I subtract 8 on both sides, I will have x equals 4. So our final our final answer as a point should be 4, negative 1, 2. Alright guys, that's it. Remember, if you need to come in for tutoring, be sure to catch me after school or in the morning. Have a good one.